So this is chapter 6b on the properties of triangles. In this chapter, we will discuss the properties of special triangles, and we will use triangle properties to solve problems. So, we need to understand some basic triangles. We have ourselves an equilateral, an isosceles, a scalene, and a right angle triangle. The equilateral triangle basically has two features. All three sides are equal, as indicated by this little line here, and three angles are equal, as indicated by a single line at the angle. In an isosceles triangle, two equal sides. As we look here, we'll notice that this side and this side are equal because of the line. And there's always two equal angles. Now the question is, whenever we have to solve problems, how do you know which two angles in the isosceles triangle are equal? So this is what you do. First, you find the two lines, and then what you do is you draw a line on those two lines until they make an X at the peak. That means that the angle right here is different, and the ones at the bottom are the same. So if we were to flip that triangle upside down or sideways, for example, this is more sideways, and I said that these two were equal, what you would do is, okay, so let's draw a line down this side and let's draw a line down this side. Oh, they cross here. This is a different angle. That means that these two ones at the bottom have to be equal. The next triangle we have is a scalene. And a scalene, well, it's easy. There's no equal sides, nor are there any equal angles. So this side could be 3 centimeters, 4 centimeters, 5 centimeters. This could be 60 degrees, 90 degrees, and 30 degrees. So nothing's the same. That's a scalene. A right angle triangle is special, as indicated by the one right angle. And the other two angles can be anything else as long as the triangle adds up to 180 degrees, as they all should actually, because that's what's special about triangles. So, as we state here, the interior angles, meaning the angles on the inside, add up to 180 degrees. So A plus B plus C. See, A plus B plus C make 180 degrees. Now the other thing we should know is this thing called the exterior angle, which means an angle on the outside of the shape. So if I were to draw a line extending past A, we'll notice that outside, and I had a triangle right here, we'll notice that this angle right here is on the outside of the triangle. It doesn't belong inside, but yet it's outside. So that is called an exterior angle. Now, what we know is that the angles on the inside add up to 180 degrees, but did you also know that if you cover and ignore the rest of this triangle, that A and D together are on a straight line? And so what's that mean? Well, A and D, since they're on a straight line, add up to 180 degrees. So sometimes we have to cover parts of our shapes to really see what's going on. So now that we've talked about these different properties about triangles and how they work on lines, take a moment here, pause, and try to find the missing angles of A, B, and X. Alrighty, let's continue. So, since we are discussing angles, we know that the angles of a triangle have to add up to 180 degrees. Since we have three A's in here, and well, this is an equilateral triangle because all three sides are the same, we just simply have to say 180 divided by the 3, which gives us 60 degrees each. So angle A is 60 degrees. In B, we know that the triangle is 180 degrees. We also know that the top angle is 44 degrees. So we could subtract it to see what we have left over that we still need to figure out, which happens to be 136 degrees. So these two angles here add up to 136 degrees. But we need to know one of them. So we take 136 and divide it by 2 because there's two b's, which ends up making 68 degrees. So B is equal to 68 degrees. And then finally, we have problem C. And we see that angle A is 50 degrees, angle B is 60 degrees. Angle C on the inside, the interior angle C, well, we have no idea. And well, we kind of need that to figure out what x is, which is we have no idea. So what you can do is you add up 50 and 60, which together makes 110 degrees. Since we know a triangle is 180 degrees, we're going to take away 110 and we find out that there's 70 degrees left over. That 70 degrees is the interior angle of C. Now, since we know that this part right here is now 70 degrees, well, if we ignore the rest of this triangle and just see the straight line and this angle, we know that this part's 70 and this part right here that's left over, well, we have no idea, but we know it's a straight line. So we can do 180 degrees, since a straight line is 180 degrees, take away 70, leaving us with x, which happens to be 110 degrees. So x is 110 degrees. Now, here's a little trick. Did you know that you can add up to find angle x, which is the exterior angle? It's the same thing as saying 50 plus 60. Because since they both share this angle right here, angle C, this is a result of these two angles added together. If you notice, this is 110 degrees and this has to be 110 degrees. Because since this one is 70 degrees, well, they share that common angle. So next time you see a problem like this, know that this exterior angle is the same as adding its two opposite angles that it does not share. That's it.